Hey everyone, today we are going to learn 11.3, which is areas of regular polygons. So our goal today is to find areas of regular polygons inscribed in circles. Regular, what does that mean? It means that all sides and all angles in the shape are congruent. So here are some examples of regular polygons. Oftentimes, regular polygons are inscribed in circles. Remember, inscribed means that they are inside of circles. So here are some examples for you. Apothem. An apothem is the perpendicular distance from the center of a regular polygon to the side of the polygon. So this distance right here is called the apothem, and we note that by using the letter A. Central angle, you've heard that term before, and it's an angle formed by two radii drawn to consecutive vertices of the polygon. So this angle right here from the center is called the central angle. And to find the central angle, you're going to divide 360 by the number of sides of a polygon. So since we have 1, 2, 3, 4, 5 sides here, to figure out what that central angle is equal to, I would just take 360, divide that by 5, which is equal to 72 degrees. Our first example here, in the diagram, ABCD is a regular pentagon inscribed in circle F. Find each angle measure. So let's first look at the measure of angle AFB. Outline that for you. We're going to use the same equation that we did in the previous slide. So 360 divided by the number of sides. Well, we have a pentagon. That means that there are 5 sides. And that is equal to 72 degrees. Part B, measure of angle AFG. I'll use a different color here. AFG is this angle right here. Well, if we know that the entire angle F is equal to 72 degrees, to figure out what half that measure is, we just take 72 divided by 2. Plug that in your calculator, 36 degrees. Now the last angle measure is angle GAF. So GAF is this angle right here. I'm going to redraw this triangle out. So we know that that angle, G, is 90 degrees from our picture. We know that this angle is equal to 36 degrees. So to find this angle then, I need to first know that all angles add up to 180 degrees. Then subtract 90 from the total. Also subtract 36. That will give me my angle measure for angle GAF. And I plug that in, I end up getting 54 degrees. The area of a regular polygon is, the area is equal to 1/2 times the perimeter times the apothem. So now we're going to use that equation to find the area of any regular figure. So once again, area is equal to 1/2 the perimeter times the apothem. Well, if you look at your figure here, we see that the apothem is 4. But I do need to figure out what is the perimeter of my figure. Let me draw another triangle in this regular figure. To be able to find out the perimeter, I need to figure out what is this distance, and I'll call that x. Well, let's look at the angle of that triangle. We learned to find the central angle. We're going to take 360 divided by the number of sides. Well, this regular figure has 4 sides. It's a square. Well, 360 divided by 4 is 90. So I know that this is a 90-degree angle. If I'm looking at just half the triangle, I then know that this angle is half of 90, which is 45. If that angle is 45, this angle is also 45. We now have a 45, 45, 90 triangle. If this side is 4, it also means this side is 4. So if you could guess what x is, we add 4 and 4 together. This section right here then is equal to 8. So now to figure out what is my perimeter, 8 times 4, and that is equal to 32. Now I have everything I need to find the area. So area is equal to 1/2 times the perimeter, which is 32, and the apothem, which is 4. Plug that into your calculator, and we get that the area is equal to 64. Let's try that again. So area is equal to 1/2 perimeter times the apothem. Well, I don't see any triangles here, so I need to figure out what is my central angle. So I need to figure out what is this angle measure. Well, let's count the sides. 1, 2, 3, 4, 5, 6. So 360 divided by 6 is equal to 60 degrees. If this is equal to 60 degrees, that means that this is equal to 60 degrees and this is equal to 60 degrees, because these two also have to be the same, because I have those two segments that are congruent. So if this is 4, this is also 4. Which means I have an equilateral triangle here. Well, I need to figure out what the apothem is. I'm sorry, before I find the apothem, I need to find the perimeter. So like I was saying, that is an equilateral triangle, which means this segment right here is equal to 4. So let's start there. So my perimeter then is 4 times 6, which we then have is 24. Now I want to focus on finding my apothem. So I need to figure out what is this distance right there. Since this is the apothem I'm looking for, I know that this is a 90-degree angle. So let me kind of redraw this triangle out. So I have a 90-degree angle. This is equal to 60. If this is equal to 60, then that angle here is equal to 30, because it's half of the entire angle measure. We also know that the hypotenuse is equal to 4, and we can see that here. If my entire segment down here is equal to 4, that means half of it is equal to 2. I need to solve for x. One way is by using the Pythagorean theorem. A squared plus b squared is equal to c squared. in my picture, A is going to be our x. That is what we're trying to solve for. B is going to be 2. And C is our hypotenuse, which is so let's simplify this a little bit. X squared plus 2 squared we know is really 4, and 4 squared is 16. That means that x squared is equal to 12, so x is equal to the square root of 12. I'm going to keep it like that for right now. And x is really my apothem. So back to our equation. Area is equal to 1/2 times my perimeter, which my perimeter was 24, times my apothem. Well, this was my apothem, the square root of 12. If I plug that into my calculator, I get approximately 41.57. So that is the area of this figure. Next, we want to find the perimeter and the area of the regular polygon. Well, before we can find the area, we do have to find the perimeter. So I have a right triangle here. I need to figure out what x is. And to do so, I'm going to use the Pythagorean theorem. So a squared plus b squared is equal to c squared. So a is going to be 6.5. B is going to be my x. And c is the hypotenuse, which we see is 8. I can simplify this. So 6.5 squared is really 42.25. X squared just stays as x squared, and 8 squared is 64. If I subtract 42.25 from each side, I then have that x squared is equal to 21.75, which means x is equal to square root of 21.75. Now remember, x is only half of our entire distance here. It's only half of it. So since it's only half of this, to find this here, we just have to double whatever x is. And so this distance then would be 2 times the square root of 21.75. Which means the perimeter of our figure would be 10 the square root of 21.75. There's 1, 2, 3, 4, 5 sides to this figure. 2 times 5 gives us 10. That's where that 10 comes from. But that perimeter is pretty nasty looking like that. So if I plug that into my calculator, that's approximately 46.64. The next thing I need to do is find my area. So remember that the area is equal to 1/2 the perimeter times the apothem. So 1/2 the perimeter. I'm actually going to use this number since that's more exact than 46.64. So I have 10 times the square root of 21.75. And I'm going to multiply that by my apothem. And if you look at the figure, the apothem is 6.5. When we plug this into our calculator, we end up getting 151.57 as our final answer.